Ladies and gentlemen, good afternoon, good morning, or good evening, depending on where you are on our planet Earth. Today, we will take a journey to another planet, the red planet, planet Mars. After the greatly successful Curiosity rover that landed on Mars in 2012, which is still fully functional and exploring the red planet, we are here today to experience and be part of a historic day, the landing of Perseverance, NASA's rover. A rover that has some amazing goals to achieve. We will talk all about that in a moment. Here with us today is William Stange, Wes, from the US Embassy in Cyprus. Mr. Stange is the Environment, Science, Technology, and Health Officer at the United States Embassy in Nicosia, Cyprus. He coordinates science cooperation between Cyprus and the United States. He has served in the US Department of State for over 6 years. His previous assignments include Armenia, Colombia, and Washington, D.C. He's from Seattle, Washington, and he holds a bachelor's and master's degree in mechanical engineering. He lives in Nicosia with his family and a Cypriot cat. Wes, hi. It's lovely to have you with us here today.
Good evening, George. Thanks again for inviting me this very important day in space exploration history. I'm excited to get to talk to you about the Perseverance mission and how that's connected to Cyprus.
It's lovely to have you with us. And ladies and gentlemen, we're both here today to receive your questions and answer as many of them as possible here live. Later on during this broadcast, in about 30 minutes, we will connect directly with NASA to watch the landing as it unfolds. After the landing, which is expected around 22:55 Cyprus time, that is in about 50 minutes from now, we will connect back to our studio to take more questions from you and wrap up shortly after. So, Wes, what do you say? Shall we start from the first video that shows the mission objectives of the Perseverance rover?
Absolutely, George. I think this video is a very interesting one because it gives you that great overview of what the mission is trying to accomplish in its search for signs of ancient life on Mars and how it's going to accomplish that. So over to you. Let's take a look at it.
Okay, let's go.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled, the crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second 2 missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
Wow.
Indeed, very interesting goals. So after the amazing success of Curiosity, now this amazing rover comes with so many objectives. So shall we start speaking about these different objectives?
Absolutely. You know, like this video was saying, the main objective here is for Perseverance to start the search for signs of ancient life on Mars. It's got this whole range of different instruments it's going to use to do that. We saw quite a few of them that were not just built by NASA, but by many of our international partners, including members of the European Space Agency. And this really is this international effort in many ways to go and begin the study for the search for ancient life on Mars. One of those key instruments they talked about, this ability to drill into some of the Martian rock, that's called a Sherlock Tool, which someone clearly got a very good a good pat on the back for coming up with that name that day at the Jet Propulsion Lab. But that is an incredible piece of equipment that's going to, as I said, drill into the rock, take a core sample and study it to see if it does have indications that it may have had life, you know, billions of years ago on Mars. But it's not the only instrument that it's going to bring with it. There's a wide range of different ways that it's going to study the geology and the weather, the atmosphere of Mars, even the microphones, so we can hear what it sounds like on Mars. We've never been able to do that before. And this is a very interesting point where there is a Cyprus connection on this mission, because throughout the entry, descent, and landing phase, and then while Perseverance is on the surface, it's collecting information about the atmosphere. And that has something to do with Cyprus's host for the Mars Upper Atmosphere Network, right, George?
That is correct. We hosted in 2018 this meeting between all the different countries that have got a substantial role in collecting data from the Mars upper atmosphere. And why is that important? Because if we understand how Mars lost its atmosphere and how Mars lost the water, it was a watery planet, it had lakes, it had oceans, and now it's a dry planet. So how did that happen? Why did Mars lose both its atmosphere to a certain degree and its water? So is there a similar danger down here on planet Earth? If we understand how that happens, then we will be able to further protect our own atmosphere and ecosystem, especially now that we feel that our planet is being hammered with so many different human-oriented dangers. So it was decided that Nicosia, Cyprus would be the permanent base of the Mars Upper Atmosphere Network, coordinating the effort between all the different nations to make sure that all together, humanity, in a joint effort, concertedly, we will go there and understand what's happening on Mars to make sure that we don't have something similar happening here on our own planet.
And this study of all these different effects and how it relates to humanity is just so fascinating. And specifically with the Perseverance mission, this search for biosignatures on Mars, it has so much potential, and it has the ability to really understand the very essence of life in ways we've never understood it before. So, you know, we could talk the entire night just about that one part, but there is so many different parts of this mission that are just so fascinating to me. And what we're going to be watching tonight is actually the entry, descent, and landing. So the actual arrival of the Mars rover to the planet's surface. And this is a very difficult and complicated set of maneuvers. And we do have a video that NASA has created to take us through the different steps involved and what to expect when we watch this happening live.
So I'm going to start a little bit on what you said about life, because that indeed is something very interesting to me. And I'm sure we can expand on this point. In fact, we have a question here from the Cyprus News Agency, from Athina Arsalidou, and she's asking a specific question about the instrument that is looking to find either ancient or current life in Jezero crater. But I'm going to come back to that. So how about we have a look at that video, the entry, descent, landing part, and see how that is going to be achieved. So if we can go to the video that shows the EDL.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Entry, descent, and landing is often referred to as the 7 minutes of terror, because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmospheric entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from a spacecraft, and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
The biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the landing site that we've given it.
The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
You look at Jezero, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky crane maneuver. And once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
Every time I watch that video, I'm impressed. I'm just so amazed at how far we've come in Mars landing and rover landings. I remember the first one in 1990, or not the first one, of course, but in 1997, watching Pathfinder land and how far and how different this is. So really incredible.
We've been through so many different stages,
yeah.
Going directly enclosing the rover inside a giant balloon to bounce on the surface. We had that. And let's say at this point that we've come to the point to refine so much the entry, descent, landing process. And it's only 40% of the spacecrafts that were sent from Earth that have managed to reach and land at their destination. Some of them haven't even been able to leave Earth orbit. Other ones have not been able to enter orbit on Mars. And this success rate has been growing and growing and growing to become a better rate. And let's remind the audiences here that even recently, the Schiaparelli lander from the European Space Agency tried to touch down on the surface, and last minute, it didn't manage to. So let's watch the space, because we're all going to be at the edge of our seat, waiting impatiently to make sure that this rover does land successfully.
Absolutely. And it's an interesting thing because sometimes there's a question of, well, how do we steer the rover in to land? The real answer is we don't. The time delay, because the distances involved are so large, the time delay from Mars to Earth right now is just over 11 minutes. That whole process of landing that we saw takes 7, which means by the time we could tell it to do something, it's already done. It's already landed. So that requires NASA to program in very specific instructions for each part of these, each part of this EDL, entry, descent, and landing process. So we can go into some more details here, because I think this video put it in a great way. When we're looking for signs of ancient life on Mars, we want to go to the places that have these transitions of water into an ancient lake bed, where there's a lot of ancient silt built up, and there are places that life could have existed. But that also is what makes it so difficult to land there. This has never been able to be done before, because the technology just didn't exist until now. And the improvements that have been made since Curiosity, building on the successes of that, have made this possible. And so let's start stepping through this. We have a video that takes us through in a little more detail, showing us what we would see if we were there. Of course, we can't actually see it ourselves. We'll just have to use our imaginations and these computer animations that have been created. So we have a video that takes us step by step through this whole process, and we'll talk through it.
So let's have a look at the landing animation video.
So this is where we start. This is with the Mars Perseverance spacecraft and rover combined, approaching after a 300 million mile journey that's lasted 7 months since it launched from Earth on July 30th of 2020. The first thing it's going to do, it's traveling relative to Mars just over 10,000 miles an hour. So it separates from its cruise stage, which is the spacecraft part that falls way behind it. Then as it keeps approaching into the planet, it uses the Martian atmosphere, which isn't much, but it's enough to help slow it down from 10,000 miles an hour down to about 1,000 miles an hour, still extremely fast. And while it's doing that, it's generating an immense amount of heat. That heat shield is protecting the rover inside as the outside reaches up to 1,300 degrees Celsius, over 2,000 degrees Fahrenheit. It would not be able to withstand it without that. And we see there on the back, thrusters firing as it slows down. And that is that enormous parachute, over 20 meters wide, that's making the spacecraft slow down further. And once that happens, it can finally release the heat shield from the bottom of the spacecraft. And then, for the first time, the Perseverance's radar and cameras can start analyzing the surface below. And that's where that concept they mentioned, terrain relative navigation, comes in. It takes radar imagery and understands exactly where it is relative to Jezero Crater, and then calculates exactly where the descent stage needs to go, firing its essentially a jetpack on top of a rover to fly it in to exactly the right position, the best landing spot. And NASA scientists have designed a series of these all around the crater where it could land. Once it slows down to less than 1 meter per second and it's 20 meters off the Martian surface, it uses that sky crane maneuver that was used on Curiosity to lower the rover down all the way to the surface. And it detaches the cable and then flies away to a safe distance. And then we're on Mars. And that's a whole incredibly detailed process. The whole time it's doing that, Perseverance is sending back signals to Earth saying, I've just deployed my parachute, I've just gotten rid of my heat shield, I've just started the descent stage. But as it's sending those signals back, we won't hear them until Perseverance is already on the surface of Mars. We're going to be reliving all of those steps 11 minutes after it's already happened. So it's incredible. Just the amount of work that's been built into this, years and hundreds of thousands of hours from the different employees and contractors, not just from NASA, but from all the international partners involved with this, all coming together for this essentially a 15-minute moment of this craft's lifetime. It's incredible.
It's absolutely amazing. So much artificial intelligence has been programmed inside this, not just the rover, the entire EDL process in order to achieve by itself the landing, because we are, as you said before, 11 minutes for the light, the signal to go from Earth to Mars, and another 11 minutes to come back to us here on Earth.
Yeah, and an interesting thing too is all of these cameras that are on the bottom that are helping to figure out where Perseverance is as it lands. It's not just to do that, it's also going to be capturing high definition video, which means in the days that follow the landing, we will be able to watch exactly what it looked like when it hit the ground and when it started its trek through the Martian surface. Never been done before. We've never been able to get that kind of information back. And it's just such a monumental achievement.
So we have a first here because we will have microphones during the EDL process and pictures, live pictures, so not live, but like high definition video coming back to us watching this whole process. But at this point, allow me to ask the question from the reporter from the Cyprus News Agency.
Yeah.
And Athina Arsalidou says, what will be the next steps once NASA finds signs of ancient or current alien microbial life on Mars or elsewhere?
Well, it's a great question. As it pertains to Perseverance, the scientists that are involved with this have said that, Mars does not have the capability of supporting life anymore. It doesn't have any water, but we know it used to because of the previous missions to Mars and the studies we've been able to undertake. It's also too cold. So for a host of reasons, scientists say that Mars does not currently support life, but it may have supported ancient life. So what Perseverance will do is, with its various instrumentation, as it's taking these core samples and analyzing them, if it does detect samples that look like they may be promising, they may have some signatures that are worth deeper study, then it packages them and it collects a series of these throughout its entire life of service, and it deposits them behind. This is the first step in a round-trip mission, because in the years to come, NASA is collaborating with other international partners like the European Space Agency to design a sample return mission, where another series of spacecrafts will go to Mars, land, collect these samples, put them into an ascent vehicle, basically just another rocket that will launch from Mars into orbit, rendezvous with yet another spacecraft, and eventually return it to Earth. And we have to consider that to say definitively if something really has signs of ancient life, there is going to be an extremely high burden of evidence and proof. It would be one of the most monumental discoveries in human civilization to be able to say that. And so we need to be able to have our best scientists and best equipment study those in detail so we can be certain of that. But this mission is the very start of that. It could be the first step into making that kind of statement, but it will take time. It will take a lot of study and a lot of effort from not just NASA, but many different international partners involved to accomplish that.
And should we find life, not proof of ancient life, Now, that would be something extremely special. And even though it's highly unlikely that we will have such an announcement, let's imagine that it does find life, current life on Mars. What would that be like if such an announcement comes to us?
Oh, I have no idea. That is one of those questions that people ponder constantly. I could not give you an answer for that, because that is such a, scientists really don't expect to find that.
That is correct. So if I go into some of the questions that we have further down here, there's a question that says, does Mars get more meteorite strikes than Earth?
That's a great question.
I would say on this one, I would say the probability is kind of similar between meteorites on Earth and or on Mars or Earth. But the difference here is the atmosphere on Earth is protecting us, where the atmosphere on Mars is thinner. Therefore, there's much more of a likelihood that these meteorites do strike in a much more impactful way than it happens on Earth.
Yeah, that's very interesting.
So
we have a little bit of time left, and I know there are a couple other aspects to this mission that are very exciting. We were talking through some of these. One thing I'd like to highlight too, it's another interesting connection with Cyprus here. Perseverance is going with almost 11 million names etched onto it, onto a commemorative plaque that's installed on the actual rover. Among those are 9,196 Cypriot names going to Mars alongside this rover. And that's amazing. The fact that this is truly an international effort, that people are being able to put their names on these rovers that go to another planet, it's impressive. What about this mission is interesting to you, George? What kind of other fun toys that Perseverance is bringing along with it?
Well, I'd say my most favorite one of them all, other than the life one, other than the Moxie, is the helicopter Ingenuity. Because tell me, when was any other mission that carried a helicopter to any other planet other than our own planet Earth?
It's never happened. Yeah, this is the first time. And what's interesting, you can only test so much. And this helicopter is going to be a potential way to help rove across Mars more efficiently. In the entirety of Martian roving history, we've done about 50 miles. It's not very far. A helicopter could change that. Now, this is just a tech demonstration, which means NASA is going to test that it works. You can test a lot on Earth, but keep in mind that the concepts that affect a helicopter, you have lift, you have air drag, you have gravity. On Mars, gravity is 38% that of Earth. The atmosphere is 1% the density that it is on Earth. You can't simulate all of those things. You can use computers to estimate it, but until you try it out and test it on Mars, you can't definitively know if it works. And this is going to attempt that once it's landed. Not immediately, but eventually.
So we have questions from people asking, what is the purpose of that? And you just said, Wes, that it's a technology test. It's a proof of concept that we have the ability to look ahead of what the rover is going to be researching. So it's helping to map the terrain, but this is also to assist future missions that are going to go there, especially when we get to the point that we're able to send manned missions to Mars. And at this point,
that's a great point, yes.
Yes, and I would like to say at this point that a lot of people have been asking, how many people will be going to Mars this time? This is an unmanned mission. We haven't been able to send people further than our own moon. So we are many years away from the ability to send humans to Mars, but we're getting every day, and especially with this mission, a step closer to achieving that amazing feat of putting people on the surface of Mars.
Yeah, that's right. These missions build on each other. Like you said, the Ingenuity helicopter is going to be this proof of concept that in the future could help a human exploration of Mars by charting out ahead. This one will just be there to pretty much verify that it works. It'll be doing a few maneuvers to make sure that it can operate as expected. But there's other equipment going with it, Perseverance, that will potentially be useful for a future human exploration of Mars. One of them that I am really excited about is this instrument called Moxie. it turns the carbon dioxide rich atmosphere of Mars just a little bit. It's not changing everything, but it can convert carbon dioxide into oxygen. Now that's useful for anyone that wants to be able to breathe on Mars because the atmosphere does not support human life. But it's also extremely important for making oxygen-based rocket fuel. So if you had an instrument that can turn carbon dioxide into oxygen, you can make air to breathe. You can also make fuel to launch a future rocket from the Martian surface into orbit. And this is another proof of concept. They're going to verify that it really does work on Mars in the conditions of Mars. So there is so much amazing science and engineering that is going into this mission that we'll get to see at the end of it. I see a couple other questions here. How long will it be visiting and researching on Mars? Great question. It's designed for 1 Martian year. Now, 1 Martian year is longer than an Earth year. It's over 600 Earth days. So this is designed to last quite a long time.
So we have to say at this point that it's designed to, but if we look at what happened with so many other missions, Spirit and Opportunity, Curiosity, these missions get extended and extended and extended. So more likely, this 1 year will keep getting extended as long as the instrumentation and the machinery of Perseverance can last on the surface of Mars, the very unhospitable surface of Mars. Because
it's a very difficult condition. You're dealing with sandstorms. You're dealing with, certainly the terrain is unlike anything NASA has attempted before. That's the very reason they're going there. Because again, the purpose of Perseverance is to search for signs of ancient life in Jezero Crater, this ancient lake bed, a place that scientists believe is a great candidate to explore further and try and find these biosignatures, as they call them. But it also involves quite a lot of ridges and sand dunes, and even the edge of this crater. There are points where it gets to 60 meters, 80 meters high. It's certainly part of the danger of landing there, but that's why you go there, is because that's where you can get some very amazing science done, is by studying these intersections of one type of environment to another where they knew this ancient lake bed was.
Now we are 11 minutes before the actual landing time. And when I say actual landing time, it basically means that at 2044, the rover is expected to touch down. But only another 11 minutes later, at 22:55, will the signal at the speed of light will reach Earth, and we will know that it has actually achieved that. Now, soon we will be tuning into the NASA feed, which we see at the bottom of our screen. But Wes, we have another 2 videos to watch. One is about the helicopter, the Ingenuity, and the other one is about the Jezero Crater. Which one of the 2 would you like to play at this point?
You know, let's play the Ingenuity helicopter. This is a fascinating bit of technology. Let's see what it's really going to look like and the work that's went into it.
Let's go for that.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to, spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
Very first flight, the main thing is we want to get the legs off the ground. And so we will basically go up about 3 meters and we'll hover there and then we'll come down again. And that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it will fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight tests at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance Rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
I see lots of more questions in the queue here to be answered, but it's almost about time that we start tuning into NASA. So either we play the last video that we have lined up for the Jezero crater, or we answer questions. How would you like to proceed here, Wes?
Let me answer a couple at once and lead that into the Jezero crater video, because I think that helps answer quite a few of these. So there are questions about what type of scientists are involved in this team, and that really is a direct representation of the mission. Again, it's searching for signs of ancient life. So specifically, there are astrobiologists, there are geologists, there are chemists, ones that are specifically trained in studying the types of life signatures that they may find on Mars. And how is Perseverance going to protect itself during this whole year? Well, NASA tests these very thoroughly to withstand the temperatures that they will most likely experience and the dust conditions they'll experience. So those are a couple of ways that the rover will survive throughout its life. But before we transfer over to NASA, let's remind everyone what exactly Jezero crater is, what it could unlock, and this video is a great way to get a better look at it.
This flyover was produced from NASA images taken from orbit. The blue circle indicates the area the rover will likely land. The arcing hills in the center, about 1,600 feet high, and are the rim of Jezero crater. The central goal of Mars 2020 is to learn whether life ever existed on Mars. It's too cold and dry for life to exist on the Martian surface today. But after Jezero crater formed billions of years ago, water filled it to form a deep lake, about the same size as Lake Tahoe. Eventually, as Mars climate changed, Lake Jezero dried up, and surface water disappeared from the planet. An ancient lake is a fantastic place to pursue our goal of looking for possible Martian life. On Earth, lakes are filled with living creatures. Evidence of that life is often preserved in the mud and sand deposited on the bottom of the lake. So, we use the rover's instruments to explore the rocks of the ancient lake bed. Here we can see evidence of the former lake. The canyon cutting through the crater rim was carved by a river. As the water entered the lake, it slowed and dropped the sand and mud it was carrying to form the fan-shaped delta. The white line is a path the rover might follow in its first 2 years, called the prime mission. During this period, we'll use the rover science instruments to analyze the lake sediments. After we explore the delta, we hope to investigate the shoreline of the former lake. To get there, we have to traverse around a sea of modern sand dunes. From this perspective, you can see former shorelines curving around a headland. We can picture waves in Lake Jezero beating on a sandy beach. And finally, we will press on to the crater rim. Jezero crater formed when a large object collided with Mars, excavating rocks from deep in the Martian crust, exposing them in the rim for us to study. These rocks would have been hot shortly after the impact and may have hosted hot springs. Deposits from these springs would be another target in our search for possible ancient life on Mars.
All right, so when do we need to switch over to the NASA feed, George?
It's 22:42. We should be starting to tune into NASA. Shall we go for the live feed for a moment and see what NASA is covering right now?
Let's do it.
Report. This is as expected. We're currently just over 6 minutes from entry interface.
Okay, and now we wait. As soon as we get to the top of the atmosphere, it will be very quickly, which is the entry point. It won't be very long before the atmosphere will start getting thicker and thicker. It's going very quickly at a fairly steep angle of 15 degrees into the atmosphere, and as it starts to slow down.
We're just under, we're about 5.5 minutes from entry interface. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
Okay, what we're looking for now is Mars Reconnaissance Orbiter should be in view soon of our vehicle and be able to listen to ones and zeros coming from a separate radio that's really designed to talk between spacecraft.
MRO reports the electro radio is powered on, ready to receive signals from the lander.
Okay, MRO is ready and able and waiting for to hear from our rover.
Mars Reconnaissance Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
flight local 1
from entry interface.
We don't need these ones and zeros, as Swati said, but to land safely, but we really need it for our own health and well-being today to keep our nerves under control. But
around this time, a second spacecraft, MAVEN, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're currently at about 3 minutes until entry interface.
Okay. Very soon we'll be getting ones and zeros, I hope, from our radio on the rover. The entry interface is nothing more than just an arbitrary place in the sky that we've defined to be above the atmosphere. But from that point on, there's definitely atmosphere, and above it there isn't.
We are 2 minutes from entry interface. Perseverance is. to transmit heartbeat tones, indicating everything is nominal.
So the tones can tell us whether something is bad or not is happening. So far the heartbeat is doing well. So the vehicle thinks it's in good shape to land, which is a great sign.
We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second. We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry. We are 1 minute from entry interface.
MROs are in receive mode.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about
So whereas at this point, Perseverance is already on the surface of Mars, and we're just waiting for the signal to arrive after the 11 minutes delay at the speed of light to come to us.
Amazing. So now we're just finding out what happened. And
yes. So this is the beginning of the 7 minutes of terror, just starting now with the 11 minutes delay of the speed of light.
Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars. The spacecraft is now waiting until it begins feeling the atmosphere of Mars to slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
The vehicle should be doing its turns right now.
MRO has lost lock.
Perseverance. We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
Yes, 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 yes.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target. Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, to the target on Mars, but instead is flying straight to the target.
Parachute.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO's reporting good telemetry log.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Yes.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars. Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Almost there.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation. We have priming of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct-to-earth tones.
As expected.
Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life. report that the descent stage has flown away to safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Oh my God.
That is fantastic.
That's amazing.
We have touchdown.
Oh, you can just see the excitement in that room. In the previous rovers that have landed, that room would be a lot more crowded with more people. But, you know, with the pandemic, they're separating as much as they can. But still, that excitement is just, you can feel like you're there. All the work that they put in over the past years that go into this, before it even had a name, they were planning it, designing it. And now they're there and they can start doing the science they've been waiting to do for years. This is amazing.
Fantastic. One more big success from NASA, landing such an amazing rover on the surface of Mars. And now the data, the science is going to start coming in.
Yeah. And in the next, hopefully very soon, we'll start getting photos of what this looks like from just the descent stage, but also from Perseverance itself, taking photos and videos around, getting some of that sound data. There's a great question. How does this information, how does the sound get back to Earth? Well, it's the same way we would do it if we're recording a sound anywhere and sending it to a friend. There's a data stream that goes back and forth, communicating between the rover and all these other satellites in orbit. All right. Wow. So now we get to see what Perseverance can do on the surface of Mars, searching for signs of ancient life in Jezero crater. This is exciting.
This is really exciting. And I have to say that all the science that is being conducted on Mars does come back to benefit us here on Earth, because there's so much knowledge that is so useful and so necessary to protect our planet, to create renewable technologies. And if we hadn't gone to, for example, to Venus, we wouldn't have known that that planet has created a greenhouse effect and know how to start protecting our own planet from the chlorofluorocarbons, CFCs, from the aerosols that we're using a few decades back. So there is so much knowledge on all sorts of different aspects that comes from the exploration of space, and especially the exploration of Mars does bring a tremendous amount of knowledge, specifically about climate change in our atmosphere.
Absolutely. And, from my background in engineering, I look at these from a technological standpoint, but you're right on science. I mean, the science we learned from these missions into space, to the moon, to Mars, they have real benefit to the expansion of our knowledge of our own planet and the universe. But looking at even the technology, NASA has a very strong history of turning technology that they've invented, created, and turning that into a private sector thing that we can all enjoy. So for people that want to learn more about this, because we got some great questions of, what does it mean for us on Earth? Why are we sending and investing in these types of things? You can go to a website, spinoff.nasa.gov, and that has just a constant stream of how these technologies that NASA has created and given to the private sector benefit humans. It's a list of things that you can look at, everything from athletic shoes to insulation in our homes to CAT scan machines. And with Perseverance in particular, some of the technology that has been used to design the drill that's going to be taking samples is already benefiting geologists on Earth with a better type of drill. But additionally, wind power, more efficient wind turbines. These are the type of things that just going to Mars has unlocked because NASA put the time to design something that they needed to solve a certain problem on Mars. And that benefits all of us on Earth. So
three of these technologies, my favorite three technologies that were spun out from NASA's space exploration, the coating on the sunglasses that we all wear in the summer. That's from the coating on the helmets of the astronauts that went onto the moon. If we speak about the MRI, that is another space technology. The improvement of the solar panels, that is helping the sustainable production of energy from space exploration. And the recent mission that was sent, Juno, to Jupiter, has enhanced the ability of solar panels to collect efficiently light from the sun and convert it into electricity, and the list goes on and on. And the very ability of us speaking now over the internet and having GPS on our phones, that is space technologies.
It is. It's amazing the types of things that we benefit from all the work that NASA does. If we could we go back to the NASA feed? This is a moment where they're really enjoying it. Let's hear what they're saying and hear how they're feeling right now.
And joining us now is the acting administrator of NASA, Steve Jurczyk. Steve, welcome and congratulations.
Hey, thank you. What an amazing day.
And how does it feel to have another rover on Mars?
It's amazing to have Perseverance join Curiosity on Mars, and just a credit to the team. I mean, just what an amazing team to work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID, and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every time we execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters. This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission, but if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions. And then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars. And then for human exploration, we have the Mars Entry, Descent, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment in our laboratories here on Earth.
We have so much to look forward to. And we also have a student question coming in from Landon. Let's take a look.
Hi, my name is Landon Applegate. I'm in 6th grade, and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions, or even as like a launching point?
Great question, Landon. Actually, we have an experiment called the Mars Oxygen In Situ Resource Utilization Experiment, or MOXIE, and it's going to demonstrate.
Okay.
So back to the studio, and that was absolutely fantastic. Now let's take a couple more questions and start to wrap up.
Certainly.
It's been a fantastic evening watching this entry, descent, and landing of Perseverance Rover. And as we said to our audiences, there are a lot of goals to be achieved by this mission. That's the helicopter, which has never been done before. There's the search for life, whether it's ancient life or current life, most likely ancient life, if we're lucky to find that. The MOXIE, the instrumentation that has got the goal to take CO2 from the atmosphere of of Mars and try to break down the CO2 into oxygen and carbon, providing oxygen to the astronauts, the future astronauts that will be going to Mars in the next decades or so, and carbon that will be used as a fuel for operations on Mars and spacecrafts to be taking off from Mars and coming back to Earth. Then we're going to be collecting samples of rocks from Mars, And those rocks, with the help of the European Space Agency in a future mission, will be returned back to Earth to have the first analysis of rocks from Mars. We've never had samples returned from Mars. And we have the, what's the other one? I forgot the other one. Can you please help me here, Wes?
Oh, there's really no end to the types of work that it's going to be done by Perseverance. You've captured them so well that it's just now we get to watch what happens and we get to hear what happens for the first time ever. It's a really exciting moment in Martian exploration history and our own planet's space exploration. So there's just so much to look forward to. As we get our last questions coming in, I'll share a couple of ways that everyone can stay in touch with what Perseverance is doing. By going to the website mars.nasa.gov/Mars2020, you can stay up to date on what the mission is doing. You can get real video, that not real time, but video that's being collected by Perseverance, and get the latest in the news. Another great resource for learning about what NASA is doing at large. If you enjoy podcasts, one of my favorite is a NASA official podcast called Houston, We Have a Podcast. It does interviews with astronauts, engineers, scientists, dealing everything from the International Space Station to Moon to Mars. It's a great way to get a broad idea of all the things that NASA is doing in human space flight.
Wes, can you please repeat that URL, because your signal was broken a little bit when you were saying the URL for...
Oh, certainly. So that will be mars.nasa.gov/Mars2020.
Okay, great. So let's see that on the screen. Is it possible to display that on the screen with a subtitle? So that would be mars.nasa.gov/Mars2020.
That's right.
That's correct. So any more questions? The questions keep coming, but there's so many questions here. It's not possible to answer all of them. Are there any?
Yeah, let's pick two more, and then we'll have to call it a night, unfortunately, and see what the morning brings from Mars.
Exactly. And let's say at this point, we will follow up and we will have another such broadcast like this one and see some of the first results arriving from Perseverance and have, again, the question and answer from our audiences to see what is the science from Perseverance on Mars. So let's have a look at a few more questions. There is one here from George, and it says, will Perseverance send soil from Mars back to Earth?
It's a great question. Yeah. So let's talk about it's a good way to wrap up too, is talking about what are we doing on Mars with Perseverance. Perseverance is there to find signs of ancient life that may have existed on Mars. And what it will do is use some of this instrumentation to take drill samples out of the rock, analyze them, and if it detects something that could be a sign of ancient life, it will package it for a future Mars sample return mission. And that will actually take that Martian rock into orbit around Mars and back to Earth. Now, these missions are still being planned. So it's in cooperation with NASA, European Space Agency, and other international partners. But the short answer to your question, George, is yes, the Perseverance rover will eventually be able to return Martian core rock samples back to Earth.
And that is actually a topic of great interest to our organization. We are doing research with a number of institutions in Europe and institutions in the USA with the support of NASA to create instrumentation to do absolute dating of the rocks of Mars. So this instrumentation is going to be sent to Cyprus in the next month, pandemic permitting, of course, and we are scheduling that to happen sometime in the summer or towards the autumn. And that instrumentation will be tested here in Cyprus on the Troodos Mountains that have got a great similarity in some areas with the rocks and terrain on Mars. And if everything goes well and according to plan, and this instrumentation proves that it does work as expected, it will be sent onto a next mission to the surface of Mars.
That's so exciting that that people and Cyprus will get to be involved in all of this, and there are these connections between Cyprus and this mission and space exploration. It's a great signal to what Cyprus Space Exploration Organization does here, and it's just a very bright future. It's a wonderful time to be living and seeing what's going on in spaceflight history.
The questions keep coming through, but
one more. Let's do one more, and
let's
then
do one more. Okay.
Yeah.
So let's select one of these questions. There is a statement here from a very good friend of the organization, DevCross, and he does say all these video games that you play on the internet with real life multiplayer games, all these technologies are technologies that are derived from space exploration, and we wouldn't even be able to play video games in our living rooms, those of us that are video gamers. So thank you, DevCross, for your point here. Yes, that is very true. So let's see more here. Oh my God, there's so many questions. I don't know which one to select, to be honest with you. Mostly I see comments here of congratulating NASA and people being thankful for our broadcast here and what we're doing. So I don't know which one to select. Here's one. The helicopter is, about the helicopter, and that's what I wanted to ask. The atmosphere on Mars is so much lighter. Therefore, how can you send a helicopter which is able to fly in an almost inexistent atmosphere, which is not breathable and not supporting something to fly? So how did they achieve that?
Yeah, it's pretty impressive just how that was done. And I mean, there are some incredible engineers that do this. Part of it, you look at, I'm pulling in a little bit of my engineering right here, but any kind of aircraft, it depends on the weight that it pulls it down, the lift that it generates from the rotors, and those two things can be controlled. So if you get rotors that are the right size, the right material to generate enough lift with a very fast motor that spins very quickly, you can generate lift. And then by reducing the weight, by using ultralight materials, by minimizing the amount of structure that's needed. And when we saw the video of Ingenuity, we see, and there's right in the NASA feed down there, you can see those spindle legs down there, very thin body, and the materials that are used in it minimize that weight. So by increasing the amount of lift it can produce, reducing the amount of weight that it has, you can make that fly. But it takes a lot of work to build that, a lot more work to incorporate that into this spacecraft, and even more so to then send it 300 million miles away through the radiation of space and to arrive and be able to operate. So it is truly, it deserves the name Ingenuity because it is an incredible achievement. And that's going to be one of the first things we'll hopefully get to see once Perseverance begins ground operations.
So as you saw, we were speaking about that, and by coincidence, NASA is showing the same thing that we're discussing here. You see there are two rotors. They're spinning much faster than a helicopter would on Earth. And just like Wes said, it must be much more lightweight in order to carry that in the lighter atmosphere of Mars. Two rotors spinning much faster than any helicopter would be spinning on in our atmosphere on Earth.
And we can simulate the Martian atmosphere on Earth because with a vacuum chamber, which is what you're seeing now, you can remove enough of the atmosphere to simulate that. You can't simulate the gravity though. There's just no way to do that. So it's a really incredible feat. And when we get some video, hopefully, or some photos at least of it operating, we'll see just how it looks in operation on Mars. So it's an exciting time.
So I'm going to say one last thing from the questions that I see here. People are saying, why don't we see live video coming from the landing? If we consider the fact that the light to come from Mars to the Earth, it takes 11 minutes. And the speed of the data that is flying to us from Mars, it's almost at the speed of old modems because it's so far and the signal is diminished. to come from such a distance. So therefore, it's not possible to do what we do on Earth, that we can watch live video, just like what we're doing right now, across continents. We're speaking about millions of miles away. So the fact that we can compress the images from Mars and send them slowly to arrive to Earth and be able to see what's happening on Mars, that is indeed a technological achievement. But in this specific mission, they're going the step further. They're taking such videos, but they can't show them to us live right now, but they will send them slowly through such speeds that I discussed a moment ago. So say that again. We have an image already. Okay, so we have an image already. Let's see.
What a far way we've come. Yeah, I remember seeing that first image back 24 years ago, and it just took a while to finally get that. And there we are. It's just minutes. So it's been such a transformation in technology, and we're looking forward to seeing what comes next from Perseverance.
So, ladies and gentlemen, at this point, I would like to say a very big thank you to Wes for joining us. A big thank you to the US Embassy for their cooperation in this broadcast. Wes, thank you.
It was my pleasure, George. Thank you very much, and good night.
Thank you. And I would like to also say a very big thank you for all of us for watching our broadcast tonight. We will be back with you again very soon to bring you scientific results. So from Nicosia, from Cyprus, thank you for watching us, and all of you have a lovely evening, a lovely day, and we'll be back soon. Thank you and good night.